During this experiment, you will be using a current balance to measure the magnetic constant. Some of the equipment you will be using includes the current balance, a high current DC power supply, handheld digital multimeters, and a position-sensitive detector. There are two setups of the current balance, and there's some differences between the equipment, so make sure you have the correct video. This is for setup number 1. Your equipment will probably resemble the picture. A key part of the experiment is to track the position of the top bar of the current balance by looking at the position of a laser spot, formed when the laser beam bounces off the mirror on the current balance. Laser beams in people's eyes are a hazard, so please use the supplied blocker panel to prevent stray beams from reaching the walkway. Make sure any beams that might go high are directed to the right, where we will have barriers and warning signs.
The current balance consists of a current carrying bar here, a mirror here, and an adjustable mask here and here connected to a frame perched on knife edges here and here. The quality of your experiment depends on these knife edges staying sharp, so please take good care of them. When unmounting the current balance on this base, you want to use the lifter, this tool here. The lifter helps you take the current balance on and off without scraping those knife edges. The thing to do is to look for these little divots in the current balance, here and here, to line those up with screws on the lifter tool here. Once they're lined up, you just gently let the current balance down onto the base. Once you're done, then you can lift the current balance off using that same tool. But remember not to lift the current balance off when it's powered, when there's current going through. This could cause the current balance to spark, and this will dull your knife edges. Let's take a closer look at the base here. There are 4 magnetic connectors on the base, and you use these to put in current or connect to your ammeter. Do not exceed more than 15 amps of current though, and don't stay at high current for more than a few minutes at a time. You may want to align the current balance bar or the bar on the base. They're held in place by set screws. On the base, set screws are here and here. And on the current balance, set screws are here and here, right next to the knife edges. So if you want to make some adjustments, you just loosen those screws, pull in the bar in and out, and then moderately tighten them again. If you do adjust the bar here, you might need to adjust weights here and here to maintain the balance of the apparatus. On the left is the DC current supply that you'll be using for this experiment. On the right is the DMN you'll be using as an ammeter,
as well as the readout of the position-sensitive detector.
The operation of the current supply here is somewhat similar to what you saw in the diode lab. You increase the voltage above what you need for the experiment, and then you can control the current. The operation of the DMM for ammeter mode should be similarly familiar. Turn it on, switch to 20 amp DC mode right here, and then you use the two inputs here and here. Let's do a quick demonstration. I'll use magnetic cable to hook up the power supply to the ammeter. And I will now turn up the current. There you go. That's it.
You can measure the laser spot position with a simple ruler or with the linear photodetector shown on the left. On the right is the box that takes the signal from the photodetector and outputs a voltage that you can convert to a position. Make sure the box is plugged in when you use it.
This is a milligram precision balance. You might want to use it to check the masses of the objects you're going to put on the current balance to weigh it down. This operation is fairly simple. There are on and off buttons. And then there's a tare button in case you want to use a container and zero the balance while the container is on there, so you can just get the mass of the objects on top. I'm going to put a 10-gram calibration mass on top of the container there. Let's see what it reads. Not exactly 10 grams. If that is an issue, then what you can do is recalibrate the scale using the two supplied 10-gram calibration masses. The instructions for recalibrating the scale are in the instruction manual for the scale on the wiki.